Hey y'all, in this lesson we're going to take a look at understanding the y-intercept of a line. Our essential question is, what is the y-intercept and what does it indicate? By the end of this lesson, we want to be able to say, I can analyze graphs in context to determine and explain the meaning of the y-intercept. We want to remember a few key items. The y-intercept is the y-coordinate of the point on a graph where the line crosses the y-axis. We want to remember that the y-axis is our vertical axis, up and down. So we can quickly identify some y-intercepts by looking at where it crosses the y-axis. In this first graph, the line crosses the y-axis at 0, 2. That's this point here. So the y-intercept is 2. On the second graph, we see that our point is down 1, so it is crossing at 0, -1. The y-intercept is -1. And in the third graph, we are crossing right through what we call the origin, or 0. So the line crosses the y-axis at 0, 0, and the y-intercept is 0. Notice that in each of these points, the x value is 0. It's always 0, comma, the y-intercept. You try these two graphs. What is the y-intercept? Pause the video now, write down your answers, and press play to hear the answer. The first graph crosses the y-axis at 0, 2, so the y-intercept is 2. In the second one, it crosses the y-axis at 0, -0.5. So the y-intercept is -0.5. Now let's look at the y-intercept of a proportional relationship. A robotic assembly line manufactures a set of parts per minute. Use the graph to verify how many parts the assembly line manufactures when it is first turned on. First, we want to think about and logic and reason through this. We're going to predict the number of parts. Now, the machine hasn't made any parts when it's first turned on. So the answer should be that when it's first turned on, it's made 0 parts. When we look at the graph of this, we look at where the line crosses the y-axis. Because this represents 0 minutes, this would also represent the amount of parts that are created when it is first turned on. So we see that the line crosses and the y-intercept is 0. And that agrees with the prediction we made. 0 parts are manufactured when the robotic assembly line is first turned on. So what we're seeing here is just the logic of at time 0, how many is made? Oh, 0 should be made, and the graph is agreeing with that. The graph of a proportional relationship always goes through 0 because that's the point of a proportional relationship. Let's look at really any relationship. Doesn't have to be proportional. Matilda and her friend are going bowling. She can rent shoes at the bowling alley or use her own bowling shoes. How can she determine how much money she'll save if she brings her own bowling shoes? So, if you've ever gone bowling, you gotta have the right shoes. We don't all own bowling shoes, so most of us have to rent. The first thing we're gonna do is we're gonna write out the number of games and the cost as ordered pairs. So we can see our bowling prices. 1 game is $4, 3 games is $8, 5 games is $12, 10 games is $22. If we can determine the cost of each game, then we can figure out from that 1 game and kind of work backwards, subtract off the amount of a game. That would be the amount of shoes. So when we graph, here's that graph now, all those 1 game, $4, 3 games, $8, $5, $12, $10, $22. We can find our unit rate just like how we've done in the past. But this is a proportional relationship. And in a proportional relationship, we cannot simply divide our y divided by x. So we can't just take 4 divided by 1 and say it's $4 per game, because it's not proportional. But we are going to find the slope by looking between 2 points. So here, if we go We'll start here, I guess. If we go over 2 games, we are going up how many dollars? Well, 5 minus 3 again, 2 games. We've gone over 2 games. And 12 minus 8 is 4. So we've gone up $4 in those 2 games. So we take $4 divided by 2 games to get that the cost, or the slope, is 2. So the cost of each game is $2. So if bowling 1 game is $4, but the cost of the game itself is only $2, well, this is where we can figure out. We can use that slope to essentially work backwards. The y-coordinate, where the line crosses the y-axis, is the y-intercept. When we extend that line backwards at the same level, because this is going by 4s, the middle one is going to go by 2, so this is 2. So the y-intercept right there is 2. Since this is where they play 0 games, that means the cost of shoe rental is $2. So Matilda would save $2 if she brings her own bowling shoes. When you have a complete graph, using that y-intercept makes it really easy to see that information without having to figure out all of the extra pieces. You try it. Here we see the y-intercept, but it's not at a really nice number. The prices for different bowling alley are shown on the graph here. 1 game, $4.50, 3 games, $7.50, 5 games, $10.50. How much does the bowling alley charge for shoe rental? Remember to find the cost per game and then subtract that from 1 game to find the y-intercept. Pause the video, do this problem, and come back to see the answer. In this problem, the slope, or the cost per game, is $1.50. So when we subtract that off of 1 game, when we take 4.5 minus 1.5, we get 3. The line crosses the y-axis at 0, 3, and the y-intercept is 3. Let's cover our summary, understanding the y-intercept of a line. So the y-intercept is the y-coordinate of a point on a graph where the line crosses the y-axis. We have 3 different scenarios. Either the line crosses through the origin and the y-intercept is 0 exactly. If the line crosses above that, it's positive. If the line crosses below that, the y-intercept is negative. So again, you see, blue line is positive, red line is negative, right through the middle is a y-intercept of 0, which is always what we have for a proportional relationship. Your next steps are to submit your 5.4 notes, complete your 5.4 practice, and take your 5.4 mastery check. Good luck, and I'll see you in the next lesson.